Step into the unknown. Welcome to the quantum room, where science meets imagination.
What if everything you can see is just a tiny fraction of what truly exists? Every galaxy, every star, every atom, together they make up less than 5% of the universe. The rest? A cosmic mystery, invisible, untouchable, and unstoppable. We call it dark matter. And right now, physicists might be closer than ever to uncovering its secret. The story of dark matter begins not in a lab, but in the stars. In the 1930s, Swiss astronomer Fritz Zwicky was observing the Coma galaxy cluster when he noticed something strange. The galaxies were moving so fast that, by all logic, the cluster should have flown apart long ago. But it didn't. Something unseen was holding it together, an invisible mass exerting gravitational pull. Zwicky called it dunkel materie, dark matter. At the time, no one took him seriously. But decades later, another astronomer, Vera Rubin, noticed the same pattern in spiral galaxies. When she plotted how stars moved around the center of galaxies, the outer stars were moving too fast. They should have drifted away into space, unless something invisible was providing the missing gravity. That invisible something became one of the biggest mysteries in modern physics. So, what is dark matter? It doesn't emit light, it doesn't absorb it, it doesn't interact with electromagnetic forces like normal atoms do. You could have a block of dark matter sitting on your desk, and you wouldn't see or feel it. Yet, without it, the universe wouldn't look anything like it does today. Dark matter acts as the cosmic scaffolding, shaping galaxies, clusters, and even the large-scale structure of the universe. It's the hidden architecture that keeps everything in balance. Computer simulations show that dark matter forms a vast web-like structure, with normal matter clumping along its strands. Without dark matter, galaxies like the Milky Way couldn't even form. So even though it's invisible, it's everywhere. For decades, scientists have tried to catch dark matter, to detect it directly. Deep underground, shielded from cosmic rays, giant detectors filled with liquid xenon wait in silence. These are the WIMP detectors, looking for weakly interacting massive particles, one of the leading dark matter candidates. But despite years of searching, no confirmed signal has ever been found. Each experiment digs deeper, and each time, the silence grows louder. Maybe dark matter isn't made of WIMPs at all. Maybe it's something stranger. In recent years, physicists have begun exploring new ideas, new kinds of dark matter. One theory suggests axions, ultralight particles that could behave more like a quantum field, gently oscillating through the universe. Another idea is dark photons, cousins of light particles that don't interact with us, but might interact with themselves, forming an invisible, dark sector, parallel to our own. It sounds like science fiction, but these models might explain the mysterious gravitational patterns we observe. And here's the twist. Some recent gravitational lensing data and cosmic microwave background readings showed tiny anomalies, patterns that don't quite fit our existing models. Could these be signs of dark matter's true nature? Or is there an entirely new physics waiting to be discovered? The search for dark matter has taken us beyond the standard model of physics, the most successful scientific framework ever built. But even this model, which explains everything from quarks to photons, falls short. It doesn't include gravity, it doesn't include dark matter, and it doesn't explain dark energy. Some scientists now believe we might need a whole new theory of reality, one that unites quantum mechanics, relativity, and the unseen universe. A possible connection between dark matter and quantum gravity is emerging. Some models suggest that dark matter could even be the quantum shadow of spacetime itself, a sign that gravity behaves differently on cosmic scales. If that's true, then the universe is far stranger, and far more elegant, than we ever imagined. New detectors like Darwin and space missions like Euclid and JWST are giving us sharper cosmic data than ever before. Every year, the boundary between known and unknown physics moves slightly forward. Maybe the first detection of dark matter is just around the corner, or maybe the real answer will change physics forever. One thing is certain, the darkness isn't empty. It's alive with secrets. Some mysteries aren't meant to be solved quickly. They're meant to remind us how much more there is to discover. Stay curious, and don't blink, because in the dark, physics is evolving. This is the quantum room, where curiosity never sleeps.